welcome to Cosmic Compass. Today, let's set our sights on the largest and most influential planet in our solar system, Jupiter. For centuries, this giant has fascinated astronomers and shaped the fate of worlds around it. But what exactly makes Jupiter so extraordinary, and why should we, standing on our small blue planet, care about this distant colossus? Jupiter is a giant among planets. In fact, it's so massive that it contains more than twice the combined mass of every other planet in the solar system. To put this into perspective, Jupiter is about 1,000th the mass of the Sun. That might sound small, but once we realise that the Sun itself holds 99.86% of all the mass in the solar system, Jupiter accounts for most of what remains. This immense weight gives rise to something fascinating. Instead of orbiting neatly around the centre of the Sun, Jupiter's mass pulls so strongly that both bodies revolve around a point just above the Sun's surface. This point is called the barycenter, the true balance point between two objects. It reminds us that even the Sun cannot fully ignore Jupiter's gravitational pull. Despite its enormous size, Jupiter isn't the densest planet. Its mass comes largely from sheer volume. If Earth was scaled to Jupiter's size, Earth would actually be far denser. Still, Jupiter's diameter stretches to 11 times that of Earth, and it is 318 times more massive. Such mass creates immense gravity. At Jupiter's cloud tops, gravity is 2.5 times stronger than Earth's. This pull is powerful enough to capture moons, at least 67 of them, tear apart comets, and scatter asteroids. Some scientists even suggest that Jupiter destroyed would-be planets in the early solar system, altering its architecture forever. Jupiter's gravity, though destructive at times, has also been protective. Think of it as a cosmic vacuum cleaner. It diverts or consumes countless comets and asteroids that might otherwise strike the inner planets. Without this guardian, Earth itself might not have remained safe enough for life to flourish. Imagine how different our history would be if Jupiter had not been there to take the blows. Looking at its composition, mostly hydrogen and helium, you might wonder, could Jupiter ever ignite and become a star? The answer is no. Although it contains the right material, it simply lacks the required mass. Jupiter would need to be about 75 times more massive to trigger nuclear fusion at its core. It has the body of a star, but not the heart. Even without fusion, Jupiter shines brilliantly. It is often the third brightest object in our night sky after the Moon and Venus. At its brightest, Jupiter can cast shadows visible even with the naked eye. Have you ever stepped outside and noticed a dazzling star that seems impossibly bright? Chances are you were looking at Jupiter. This brightness is why the planet has long been a favourite target for amateur astronomers. With even modest magnification, the planet's striking cloud patterns reveal themselves. So, what gives Jupiter its appearance? Its upper cloud layer, only about 50 kilometres thick, is composed of ammonia crystals and compounds known as chromophores. These rise from deep within, heated by Jupiter's inner energy, then interact with sunlight to create the colourful bands that stripe the planet. Where the bands meet, turbulence creates storms of unimaginable scale. The most famous is the Great Red Spot, a vortex so large that Earth could disappear inside it. Observed since the 17th century, it may be a permanent fixture of the planet. Yet over time it has been shrinking, leaving scientists puzzled about its future. Its deep red colour too is mysterious, likely the result of compounds broken apart by ultraviolet light. Nearby, a smaller storm, nicknamed Red Spot Junior, formed from the merger of three storms and continues to thrive beside its giant neighbour. Beneath the swirling clouds lies an interior that defies easy study. Jupiter is thought to be about 90% hydrogen and 10% helium, with traces of methane and ammonia. As pressure increases inward, hydrogen transitions from gas to liquid, and deeper still, into a metallic form capable of conducting electricity. Somewhere beneath all this lies a dense core of rock or ice, though its exact properties remain uncertain. Conditions inside Jupiter are so extreme that they cannot yet be recreated on Earth. Did you know Jupiter also has rings? They are faint, nothing like Saturn's dazzling bands, but 4 distinct rings circle the planet. The brightest is only about 6,500 kilometers wide, while the others are wide, yet almost invisible. Among them is a subtle feature called the Métis notch, a reminder that even Jupiter carries this delicate adornment. Another striking feature is Jupiter's magnetosphere. Powered by its metallic hydrogen interior, the planet's magnetic field is 14 times stronger than Earth's. It is the largest and strongest planetary magnetosphere in the solar system, second only to the Sun itself. This immense field channels solar wind toward the poles, producing brilliant auroras. It also shields Jupiter's moons, sparing them from the full force of the Sun's charged particles. Speaking of moons, Jupiter has at least 67, while most are small. 4 stand out. The Galilean moons Io, Europa, Ganymede, and Callisto. Each is a world in its own right. Io seethes with volcanic fury. Europa hides an ocean beneath its icy shell. Ganymede is the largest moon in the solar system, even bigger than Mercury, and Callisto bears the scars of ancient impacts. These moons alone could justify entire missions, and indeed, they are at the forefront of planetary science today. Jupiter is the 5th planet from the Sun, lying beyond the asteroid belt at an average distance of 778 million kilometers, or 5.2 astronomical units. It takes 12 Earth years to complete a single orbit. Despite its vast size, Jupiter rotates faster than any other planet, spinning once in just 10 hours. This rapid rotation, combined with its gaseous form, causes the planet to bulge at the equator. Unlike solid worlds, its equator and poles do not rotate at the same speed, a phenomenon known as differential rotation. If we look at Jupiter through infrared eyes, we see its immense energy output glowing with internal heat. On its surface, impacts from comets leave scars visible from Earth, reminders of the role it plays as a shield. A collision that devastates Jupiter might have ended life on Earth. In many ways, we owe our existence to this gas giant. It is not just a spectacle of beauty, but a guardian of our world. So, what have we learned today? Jupiter is a planet of extremes, massive beyond imagination, turbulent yet protective, a failed star yet a brilliant light in our skies. It sculpts the solar system, protects our fragile home, and dazzles us with its storms and moons. What do you think? Did you discover something new about Jupiter that surprised you? And which of Jupiter's features fascinates you most? Share your thoughts in the comments below. If you enjoyed this journey, consider sharing it with others, because the more we grow, the more cosmic stories we'll be able to tell together. Until next time, let's keep exploring the universe.